Alright, so in this video I want to talk about a pretty important concept called a transformation. We use this a lot in algebra, and the idea in the broadest sense to transform something means to change it around. And there's four main ways that you can change a graph. You can move it left or right, and that's called a horizontal translation. You can move it up or down, that's called a vertical translation. You can dilate it. If you've ever been to the eye doctor and they put those drops in your eyes, dilating your pupils means changing the size. You can either make them bigger or smaller. And then you can reflect it over an axis. Okay, when you're doing those things, what you're basically doing is taking the most basic form of a graph, and that's called a parent function, and you are reflecting it. So the parent function for any line is y equals x, and y equals x looks roughly like this. Not going to be the straightest line, but hopefully you can still tell. So that means if we do something to this, like if we write it in mx plus b form, 3x plus 1, that's going to take the blue graph and it's going to somehow change it around. And we'll see some examples of this in just a sec. The parent function for a parabola is y equals x to the second power, and it looks roughly like this. When you talk about this more later in the course, but if you connect the dots right here, you get this kind of U-shaped graph right here. Looks like that. Okay, and then obviously if you were to do stuff to it, if you said, y equals, let's say, x squared plus 3, that's going to take the parent function, which is that blue graph, and change it around. And this, the absolute value, we've seen this in a previous section, that's the V-shaped graph. That's what the parent function is for that. And then the same idea, you can take this and you can start doing stuff. Let's say I add 2 and I put a number out front somewhere inside. Okay, the way to remember these first two translations, the horizontal and vertical, is with this little saying right here. Add to x, go left. Add to y, go high. So what does that mean? I'll give you a simple example, and then, like I said, I'll show you some actual graphs that are neater than the ones that I'm drawing, so we can follow this. So here's what we mean. Let's stick with a parabola, because that's the U-shaped graph that we'll talk about. So there's the parent function, y equals x squared. And I'll give you two examples of transformations here. So let's do this one, x squared plus 1. And then underneath that, let's do this one. Okay, x plus 1 squared. So they look very similar. They both have a plus 1. I'll tell you, though, that this one right here, the plus 1, this is taking y, because y equals x squared. It's taking the y, and it's adding 1 to it. And this says when you add to y, go high. That means this is going to move this graph higher. It's going to move it up 1. This second example right here, okay, the x plus 1, this is first adding 1 to x and then it's squaring it. So you're adding to x right here, which means you're going to go left 1. Now here's a question that might occur to you. Why, if I'm adding 1, why would I be going left? Because when I think of adding, I think of over here, I think of the positive x values. And here's how you can answer that question. Think to yourself, let me write it right under here so we can see it. Ask yourself this, what x value would I have to plug in right there to make 0 get plugged into that function? And the answer is you'd have to plug in -1. But if you look in the graph where I just plotted -1 and I draw a new parabola right there, which direction did I just go? And the answer is I went to the left. That parabola is going to reach that point earlier in the cycle. It's going to reach it. It's going to reach 0. 0 is going to get plugged in here at -1 instead of at 0, like in the parent function. So now I want to show you what some of these pictures look like. Okay, so these are a series of parabolas. I'm going to show you all of the different types of transformations here. So we have the red one is the parent function. This one right here, I want you to try to do these as we're going. See if you can kind of anticipate what the graph's going to look like. So this is, you can see these four right here, x plus 2 squared, x minus 2 squared, x squared minus 2, x squared plus 2. Those all look very similar. This one, though, is taking the y and it's adding to y. So we said before, add to y, go high. This one is adding 2 to y. So you can see that blue graph that I just turned on, that has moved the graph up 2. The one underneath it, we're not adding to y, we're subtracting from y, so that means we're going to go lower. We're going to go down 2. You can see that green one just went down 2. This is subtracting from x. Our rule for x said add to x, go left. So think about it. If we're subtracting from x, where do you think we would go? And the answer is we would go right 2. And you can see that orange one just popped up. That's right 2. This one is add to x, go left, so we'll add to x, and you can see it went left, that purple one. Okay, these other two right here, these next two, minus x and then minus x, again, they look very similar, but these are both going to be reflections, and here's why. You're going to take, this says take all the x values and make them the opposite sign. So if they're positive, we're going to make them negative. If we're negative, we're going to make them positive. So you look at this graph right here, where my cursor is moving, those are the positive x values right there. Okay, x is positive in this first quadrant. So if I take all those positive x's and I suddenly make them negative, they're going to swing over to the second quadrant, and vice versa. The ones in the second quadrant, when I make those negative, are going to switch over to the first. So watch what that looks like. Okay, you can see that black graph is actually the exact same as the red one, and you can see I'll turn it on and off. These are the same graphs, and the reason being is that if you reflect over the y-axis, because that's what this does right here, the negative x takes all the x's, makes them negative, that means it reflects over the y-axis. If you reflect a parabola over the y-axis, it doesn't look any different. It's the exact same because the parabola is symmetrical, meaning you can fold it on top of itself and it looks the same. Okay, this next one is first squaring x and then it's making a negative, so it means it's taking the y values, it's taking the whole function, which is x squared, which is the y value, it's making that negative. So y is positive in the first and second quadrant, so where my cursor is moving right now, it's positive in those two quadrants. If I suddenly take all those y's and make them negative, I want you to think about where it would go, what would happen. And that's what would happen. It would reflect it over the x-axis. So when you make the y's negative, you reflect over the x-axis. When you make the x's negative, you reflect over the y-axis. Okay, last two I want to show you, 2x squared and half x squared, this is going to be vertically stretching or shrinking it. Okay, and actually there's one more I want to add here, so let me just move this one down because we'll be doing a longer example later. Okay, there's one more I want to add, so let me get rid of that for a sec. Let's do this one as well, just so I can show you kind of all the different combinations here. So let me close that parentheses. We'll talk about this in just a sec. Alright, so this right here, the 2x squared, if you take something and you multiply it by 2, you double it. The question is, do you make it bigger or smaller? And the answer is you make it larger, so this is going to vertically stretch it. And I just turned that on. You can see the blue graph is vertically stretching it out. But if you vertically stretch something, then at the same time you horizontally shrink it. Okay, think about if you had like a slinky or something that vertically stretches out. When you stretch it out, it kind of compresses in horizontally. Okay, this next one, the 1/2, is going to take x squared and it's going to cut it in half, meaning it's going to shrink it vertically or make it smaller. And that green one, you might say, well, that looks like it got bigger, and the answer is yes, it did get bigger, but which direction did it get bigger in? We said it vertically shrunk it, which means horizontally it will do what? And the answer is it horizontally stretches it, and you can see that. Okay, what if the 1/2 is on the inside of the graph right there? Well, that just means you're going to take 1/2 and square it. So that actually, and I'll prove this to you in just a sec, 1/2 squared is actually 1/4. So let's watch that happen. So that's the horizontally expanded one. And then this other one that I just turned on, you can see it's the exact same. The green and the orange are the same. This is just another way of horizontally expanding it. So in the next video, we'll actually do some examples of trying to find specific transformations and describe them.